Hi everybody, thanks for coming to this last talk of this awesome conference. Patrick and I will talk about some drivers that we have developed at DataStax. So I guess by now, most of you guys have probably seen some of this project or even started to play with it. So we're going to give you a little bit of insight about this Java driver and in general, actually about the general kind of architecture we try to develop for our brand new drivers. It's a fairly new vision for Cassandra. It's a long-term investment, so we don't expect any of you guys to switch from your current Swift driver or your current Swift-based investment like right now. It's just really a long-term investment and long-term vision for Cassandra to make it simpler to use. So we can start by actually this whole vision of making Cassandra simpler. Just start from CQL. Before CQL, you had a fairly inconsistent interface for Cassandra. You know, we have some different way of expressing queries, whether you were in Java, in C# or in the CLI interface. It was not really exciting. It was very confusing, very complex, but at least it was a cheap way for the Cassandra project to bootstrap some driver for every language. So now we've got this new vision that come with CQL, and I guess most of you guys were at Sylvain's talk right before, so we won't spend too much time introducing CQL. Basically, CQL is not just actually a query language, as the name implied. It's also a fairly updated data model on top of Cassandra with a thin abstraction layer on top of on top of the classic data models that you're used to use in Cassandra. So you know Cassandra as a column-oriented database. In CQL, what you manipulate is actually just a bunch of denormalized tables, just like those that you're used to use in SQL, in your MySQL relational database. The only difference here is that you don't have any joins, and you're not able to do any kind of aggregation in your queries. So as you will see in the example later, and I guess most of you are familiar anyway, where it's definitely an SQL-like query language. The goal is really to leverage all the knowledge and all the knowledge of your team and of developers out there in SQL. So it's not schemaless anymore. We believe that even if schemaless sounds cool and is pretty trendy in the NoSQL world nowadays, we believe that actually anyway you always end up having some schema definition, even if it actually ends up being some schema written in Python or in Ruby or whatever, because in your language, in your application logic, you actually need some kind of awareness of the actual schema that you manipulate. So here you've got a real schema definition, and maybe what you haven't seen actually, because there's a lot of noise about CQL, but CQL also come in Cassandra 1.2 with a new native protocol. That's a protocol that will come as a replacement for Swift. So as you know, Swift is an RPC framework, and as I've mentioned, it's a fairly cheap way. It has been a fairly cheap way for us to give you some driver for pretty much every language for free, because the Apache Cassandra project was just delivering some IDL, and then you were able to compile some client for pretty much every programming language out there. So it was great, but now that Cassandra is getting mature, it starts to be fairly limited. It's actually Swift is just a request response protocol, so it's not really great because we want to move forward with some streaming. We want to have some notification. We want to do a lot of things in Cassandra, and this Thrift protocol is actually starting to be a bottleneck for the progress in Cassandra. So, and just to stress it, because it's very important, it's not because there's this new investment that we will start to drop any kind of Thrift support. We totally respect all the investments that have been done in the Thrift landscape for years. We know that there's a bunch of business and a bunch of applications that run on top of this interface. So it's simply a brand new interface on which we start to work and invest for now and the future. But Thrift will keep remain being supported for some years. For sure, you're totally safe with your investment. So Patrick will actually give you a little bit of insight about what it's like to data model some stuff in this brand new SQL landscape.
Okay, so more data modeling. How about that? I bet everybody was in my data modeling talk earlier. Well, and I'm just going to cover this really quickly, but kind of in the perspective of our SQL driver. So if we've talked quite a bit about SQL from a data modeling perspective, and really it's because we're talking about your applications. You know, SQL is a great way to describe that data model. So, of course, with your data model, Cassandra, living closer to your application, we're trying to describe things. You know, I want to do something on my web page, like I need some object or some sort of information. So we're trying to get this closer to your application where it's less of a generalizable pattern. So Cassandra doesn't, you know, of course, doesn't do joins. It's not as good for seeking, things like that. It's better whenever you can predetermine your data model beforehand. So that's what it's about. When I say it expresses your application's intent, is really from the top down, from the application level. Now, when I do my data modeling talks, I talk a lot now in CQL, which is so much easier, I think, in a lot of ways. When I did them in Thrift, it was harder because I would use like CLI, but there's no descriptions. There's nothing that would say, and this is what your data model looks like. It was more of descriptive where, and we'll store some time series data in a column family later. There's nothing that said that in an actual written out data model. So in the data models that I've gone through, now I can describe them to you, and now we can use this driver because that's what it's using. So we have kind of the 1-2 punch here. If you were at my talk earlier today, all of that I have implemented in an example code. And so that's sitting out there on GitHub somewhere. I haven't made it all public, but so that it just gives you that kind of, okay, I'm taking from the conceptual stage now down to the model stage or the actual usage stage. So I think that's enough about data modeling. If you want to know more, I got plenty more resources out there, but I think that's enough for this talk.
So let's actually just have a quick look on some details on SQL3, a very quick look once again, because I guess most of you guys have already seen Sylvain's talk on the state of SQL, and if it's not the case, I strongly suggest that as soon as it's available on YouTube, you just have a look at the video. We'll try to have them available as soon as possible, especially because I think there were not a lot of room in his conference room. So as I mentioned, in SQL, everything is just a table, just like as you were used to manipulate in SQL. So it's really, there's no wide rows anymore. Wide rows are actually broken up in several rows in this static table, just like you were used to see in some denormalized table in SQL, or maybe in some result set of some joint query in MySQL or Oracle or whatever. So what we've got is actually this table that, once again, is just like a relational table, but the only difference is that instead of defining a single primary key, we define you can actually define a single primary key, but you can also define when you need to store some more complex data, you're able to store some, to define a composite primary key that is basically made of a partition key and of one or several clustering keys. So it's all about data locality here. So basically, the primary key is just in order to define on which node you want all your data to be co-localized, to be co-located, and the clustering key is then to define how you want your data to be co-located on the disk. So it's first to co-locate the data on a single node and then how to co-locate it on the disk. So actually this example can simply be created with this very simple SQL-ish SQL statement. So as you can see, the learning curve for SQL is definitely super small. It's my own personal experience is that actually I could get up to speed with SQL way faster than the amount of time it took me with the Swift interface. So I don't want to dig deeper in SQL because I guess you've heard about it a lot of time during this conference. So let's have a look at the actual new driver architecture, the architecture that we want for our new drivers. So we totally want to leverage these brand new protocols that come as a replacement for Swift, and we also want to leverage SQL and to make sure that you don't have some noise with any legacy interface from Swift. So that's why we come with a brand new architecture. We don't try to to merge or mix any kind of old and new style because we want something that is really clean and simple for newcomers as well as for experienced users. So everything is based on this new protocol. There's no more Swift dependencies. And we will work to provide for every major language these three kind of API. So what I call a SQL API in this architecture is basically a fully dedicated, an API fully dedicated for SQL that is designed for every very specific features of SQL that is able to support all its very cool features. DB API is just an adapter that we will try to provide for all this language to integrate with the standard DB API such as JDBC, DB API for Python and everything. It's not meant for any production usage. It's just meant for some simple integration paths with some existing tools or ESB, ETL, whatever tools or middleware or library you want to integrate with. So, and once again, it's pretty cool for us to write this kind of adapter because what we've got right now is some tabular result set along with some string queries, so that actually totally fit in JDBC and other standard DB API. So that's pretty cool to leverage this similarity. And last but not least, we will provide an object mapping interface for every language. We are not talking about any kind of ORM, any kind of object relational mapper or whatever. We are really talking about being able to map from an object to a query and then from a result set to an object just for productivity. From a productivity standpoint, it's we don't want to get into the middleware and framework business, you know. So let's have a deeper look at this Java driver by itself. So it's come with a bunch of very interesting features that might by themselves make you want to switch to this new architecture actually. So we really consider it as our reference implementation as this driver has been implemented the first. Java the Java community is by far the biggest Cassandra users community. The driver is entirely based for its network I/O on Netty. I guess most of you guys have heard about it. It's a network I/O library that has been written by JBoss, which is fully asynchronous based on some non-blocking I/Os. We support prepare statement from the very first version. Same issues as the relational words, same solutions. We've got some text query, and we don't want to carry some text over the wire, especially for large-scale applications. We've got a fully automatic and standardized failover strategy across all our drivers. So we want to avoid the issues that you used to have, that is, whenever you were using Hector, Astyanax, Picasa, and any other drivers in your architecture, it was pretty tough to know what was the failover strategy of this driver and what was the load balancing strategy of this other driver. So when you had to do some troubleshooting, it was pretty tough to make it. So here we will really try to have, and not just try actually, we will really work to have a standardized architecture and standardized way to deal with all these issues. Same goes for node discovery. The driver will automatically discover all the nodes. You just provide some scene nodes, and the driver is able to receive the complete list of nodes in your Cassandra cluster. So the new protocol that we've added in Cassandra 1.2, which is this CQL native protocol, come with some pretty interesting features. And by far the most interesting one is that we support request pipelining. Request pipelining is the fact that we don't have to wait for the response to come before we send the next request. We just send a pipeline of requests to the server, and then we receive the response, possibly out of order, and we totally manage that, because along with each response and each request, we receive some stream. We've got some IDs that let us dispatch the response to the white thread that is waiting for it. So we also support notifications. Notifications is a pretty cool features as well, because up to now, most of the most advanced client libraries for Cassandra had actually to poll some Cassandra nodes in order to retrieve the whole topology or all the schemas or everything, and to keep it up to date with the time, because obviously the topology is meant to change with time. Maybe if you lose a node, or if one of your ops is adding some more node. So here, the client can just register with one of the nodes for some event, for some notification, and it will receive some event as soon as a node has been added or a node has been removed from the cluster, so that we can update our load balancing policy very quickly. So the driver is fully asynchronous. That's something very important for us. It's not to start again this long troll about synchronous versus asynchronous. We don't want to debate about performance here. And just by having a fully asynchronous architecture, it allows us to let you push a bunch of requests in parallel without having to set up any kind of thread pool, any kind of concurrent threading, any kind of concurrent execution in your code, in your application code. We just provide some asynchronous method for you to push your queries, and you don't have to tune any kind of thread pool or whatever. It just all executed asynchronously through some non-blocking IOs. So the driver maintains a bunch of connection per node. The amount of connection depends on the current pressure on this node. And each connection is able to handle a bunch of pending requests. So by default, we can handle as much as 128 pending requests per connection, which clearly reduce the pressure on the amount of connection we need to keep per node, which is actually pretty great when you've got to work with a bunch of application servers in front of your Cassandra cluster. You don't have to keep any more thousands of connections opened on your Cassandra servers.
Before you go any further,
yeah.
I know there are people out here, because I know you, that have this problem with Thrift where you're running a lot of application servers all hammering a small group of Cassandra servers. Because maybe your Cassandra servers can keep up, no problem, but the application servers want to have serviceable threads. And I've done this before when I've had to tune down Hector the amount of threads per application server, because you had 30, 40 application servers, they were all going after, say, a 6-node cluster. And that just creates a lot of TCP connections. This fixes that problem. I've actually put this into production where it really made a difference. And I have to thank you for that. Because it made my life a lot easier, because what was the answer before? HSHA. And that was the half sync, half async connection on Cassandra, which is a compromise, which I don't like to make. So from a real-world perspective, you think about what we're doing with our applications where Cassandra can just start scaling like crazy, you need to have something to keep up with it.
So to have a look at what actually happened, let's look at the whole read and write path for a single query that a client thread, for instance, will try to push on a node. So a client thread issue a request and push it against the driver. The driver will, through its load balancing strategy and through its internal logic, pick up a node and then pick up a connection on which to push this request. The node will receive it, will eventually answer to this request. The driver will receive this response and will then dispatch it to the client thread. Basically, it's here because we will see in our API, we actually provide you some future object. You can just have in your client thread a bunch of concurrent future objects, and the driver will just dispatch the incoming response to every of these future objects. So you will quickly get used with this new driver to use and abuse of all this concurrent programming, of all this concurrent request execution. You don't have anymore to try to pack as much as possible all your requests or whatever. You can, because we've got some request pipelining, you can totally push a bunch. If you've got to fetch for hundreds of ID, instead of having a multi-get request, you can simply push a bunch of requests that will be dispatched all over your cluster without creating any hotspots, you know. So maybe, Patrick, you can have a look at the API.
Okay. How about some real code? Yeah. Yeah. Here, I'm going to move around because it's kind of late in the day, right? And we need to move our heads a little bit. So, yeah, this is the trouble being the last talk of the day, right? Because everyone's like, oh man, 2 days of this. So, all right, this is going to be simple because it is simple. So what I'm doing here is I'm just creating, so all this code's up on GitHub right now, by the way. So I'll tweet out the link later. So if you want to follow me, then you can get the link for this. But so what I've done is created a working example, and we'll go through several of these. We'll go through some points about how it works, and then I'm going to show you some actual examples. So if you've never done a connection to Cassandra before, this is going to look pretty easy. If you've done it using other drivers, this is going to look really easy. So really what I'm doing here is I just have a list of connection points, and my key space is VideoDB, which is my example database that I use everywhere. But it's just creating a cluster. That's it. I'm creating a cluster. I add the contact points. Those are the different IPs. And I say build. Done. Walk away. So when I make the connect, that's when it actually fires up everything and to that particular key space. If you've used other drivers, that was a few more steps in there, and there was a few more things to worry about, but not as much. Once I have this session, I'm done. Now I can start using that session for actual interaction with the database, and that's it. Next. So this is going to be a basic write. Now this looks really ugly because I had to use a string buffer to do this. But what I'm going to just tell you right now is this is the not preferred way to do this. So when I wrote Oracle code, one of the things that security people would do was tell me, you're never going to insert a string. You're never going to do an insert with a string because you just opened up the door for a SQL injection. So what I'm doing here is I'm creating a SQL injection. So I'm giving you the easy example of, like, we could do this if we want to, but I have other examples that will keep you from doing this. This is the non-preferred method. But basically what I'm doing is I'm taking that CQL statement, the insert into, I'm taking this API, I have a user object, I'm taking the first name, last name, blah, 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 and then I just say session.execute. There was no mutate, there was no string, any string serializers, anything like that. It's just taking that one command and doing the insert. I think I got one more after this, don't I? You want to hit this next button?
Oh, sorry.
Yeah, okay. Wait a minute. Is this the same one?
No, that was the following one.
Oh, okay, now we're doing the read. Now we're doing a read, okay, thank you. It's late in the day for me too, okay? It's been a crazy couple of days. So the read, same thing. But if you recall from my data modeling discussion, so I'm gonna do this select star on the user table. And the username is the row key. So now I'm gonna just get a bunch of CQL rows. One of the things I mentioned in my data modeling talk is that now CQL is going to give this row abstraction. So now we have rows that we can iterate over. And those make so much more sense in a programmatic setting. Look at what we're doing. I get a result set of rows. I just iterate over those rows. Even if the actual storage implementation is multiple columns in the same row, CQL giving us multiple rows as its abstraction will make this a lot easier than trying to iterate over multiple columns in a standard column family. So this is demonstrating just that. It's that simple. You get that particular, you just select, you get a row set, and you just iterate over the rows and pull the things out, and that's done. All right,
and once again, here we are doing a concatenation, a string concat, which is not the way we suggest you to do it.
So this is bad.
Here's the way we actually suggest you to do it.
Yeah, the prepared statement. And this is how I did it in Oracle too. So the security guys would always, you can't do a string, use a prepared statement. Okay, got a prepared statement. So now we have prepared statements, and they're actually faster too, correct? Is that right, Mikhail?
Yeah.
They're faster, okay.
They're totally faster because we just push from the client to the server a prepare statement ID along with some parameters. That's all. There's no string over the wire or whatever else. It's just some basic parameters transferred as some binary strings. That's all.
So this is the way we would prefer you do it. And there's a more expanded way to doing this. But this prepared statement, so earlier what I had done is created a statement. It was just an insert with question marks. And so that's what that set user is all about. I didn't show all that other code. I know that's what your question was. The complete example is on GitHub, every bit of this. So it's abbreviated because I have this much space. And you don't want to have to, we actually had a hard time trying to cram that much into it because you really want to make it so you can read it. If I put my entire code base up here, I could read it from here. So we don't want to do that. So anyway, what happened before is I had created an insert statement with question marks in it. And those question marks are now being replaced by the username, first name, last name. When I bind and then I do a set string, this is just like what we did with Oracle, MySQL, JDBC drivers, where we do a bind, and then we have a prepared statement and setting values inside of it. But once we're done, execute, done. I don't think I have one more. Okay, asynchronous read. Now we're getting into the cool stuff. And this is, I think I've talked to several of you about this, where when you have a cluster of Cassandra, you don't want to just read it one at a time, because what's the point? If your data is spread out randomly around your cluster, doesn't it make more sense to read things in parallel? And an asynchronous read is where this driver really starts to make sense. And so what I'm going to do here is I'm doing this get videos by username. So there's a lot of stuff going on here. I'm going to try to explain what's going on. But essentially what I'm doing is I'm getting a bunch of video titles by a single user. So me, a user, P. McFadin, I got like 20 videos out there. I have a prepared statement that will go get the IDs for all of those. But what I'm doing is I'm creating this futures list. And so I bind it to my username. I do a session execute, so now I have it. And as I'm iterating over each one of those video IDs, I'm creating a future for that. So I do a futures.add. So as soon as I do that, it's running that command. It's going in parallel and running those out. Boom, 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 boom. As I'm working through my code. So these are what's happening in the background. So when I get down here, finally, I'm going to iterate over all those futures that I created. And a future is just something that's running right now. It's on a thread. When I do a future.get, and I did it uninterruptedly, if you do it without that, then you'll have to catch the potential thread interruption because there's threads. But I'm getting it uninterruptedly. That's when we block at that point, and I just iterate over that. Now, the intent is that with the correct row key going out to the different servers, all those things are going to be happening in parallel. Like if I had 25 videos, it's going to make 25 parallel calls around my ring. And that's what I'm hoping for, is to get that parallel task running for me. If, let's say I had 100 nodes, if I had 200 nodes, I would want to take advantage of that fact and run everything in parallel. So what's going to happen is the slowest query is going to be the slowest part of the entire thing. The rest, I'm not going to do running things in serial like I did before, where I'm going to have to stack up like the slowest query, the second closest, and the third. I mean, it wouldn't be additive. It would just be the one that's the slowest. So this is much more efficient whenever you're grabbing a lot of data. And that happens if you use one of my index patterns for data modeling, you're going to get back a bunch of IDs. And I want you to go get all those IDs from that index. This is how you could do it, and then do it very efficiently. Next. Oh yeah, now this one's tough. I'm going to go through this, and Mikhail's probably going to correct me, because he's a much better concurrent programmer than I am. But this is one that I really do want you, I'm going to go through it a little bit, but I really do want you to go look at the example if you're really interested in how this works, because this is just a snippet of that code. So what we're doing here is something very similar, where we're creating futures. But in this case, I'm actually creating background threads that are running independently, all at the same time. And there's some craziness going on here. And I have a lot more comments in my code, too. But very similar, I'm just grabbing all my video IDs, and then I create this runnable. And this is just another thread, and I'm executing this background. But what this background is doing is it's iterating through all of these potential video IDs and grabbing them all in separate background threads, independent from each other. This is that concurrency thing that really is going to be fast if you're doing it right. But as it's grabbing each one, it's putting it into a, what is that? I don't even have it up there. It's some sort of a hash map or something. Yeah, it's a hash map. And it's creating this long list of all the IDs. So this is, again, like where you have an index where you grab a bunch of IDs, and you're going to suck them all in and hopefully do these things in parallel. This is what's executing in the background, one at a time. And with the listener, you're doing that without any blocks, and it's all happening in the background. So again, you're trying to take advantage of the speed and the efficiency of doing things in parallel. Anything to add on that? It's hard to add. Okay, we'll downshift a little bit here. That was a little crazy. The query builder. The query builder is, again, it's along the line of where we want you to do things instead of using just creating a string and then dumping that directly into it, is you're actually building the query through API. So the query builder is pretty interesting. So I create a query, and you'll notice it looks very similar. You know, I'd select .all from, and I grab the, you know, from the column family and the key space, and then where, and then I have an equal clause, and then I put my limit at the end. The query builder, I think, I understand a lot of the security, people who do auditing on security, they require this. We've talked to some customers that say, no, I have to have a query builder. I can't even do this any other way. I can't even use a prepared statement. So I need a query builder. This has gone through quite a few checks. Now, one of the things that I'm doing along with this is I also have the ability to set the consistency level. I've told you probably, if I've ever done any consulting on site, is a consistency level is something you set per request. That doesn't go away. Thrift and CQL both have the way that you can set the consistency level. I want this request to be at quorum, or at 1, or at all. And so in this case, for this request, I set my consistency level to 1. Same thing that happens after that. I build my query, I execute it, and I get my videos out. Next. Next one. Oh, this is you.
So, so let's get back to some architecture with some other very interesting features in this driver. I've mentioned that we were handling failover, load balancing. So let's have a look at actually how we organize everything. So in this diagram is actually showing you what kind of step do we have in our query execution process in our driver. So whenever the client is pushing some request, it will be routed through some internal load balancing policy, which you will see in a few slides that you're able to customize and fully re-implement, or you can just pick up the load balancing policy that you want, actually. This load balancing policy will then pick up one of the nodes to which we should route the request. If this node turns out to be unavailable, like it's the case in this number 2 rows here, we are trying to reach a node which is not available, then the load balancing policy will actually pick up the next node in the list of nodes we wish to push queries against. That's the case in this third rows in this diagram. Actually, it actually works perfectly. And so this node is able to push a request back to our drivers. And this response will go through the retry policy. This retry policy will actually figure out whether it needs to give it a try or not if it turns out that the response we received was a failure. And then it goes through a dispatcher that will simply figure out which client thread should receive the response. So talking about these load balancing policies, actually, we obviously have some fairly basic balancing policies, such as a round-robin one, which simply spread all the load evenly across your cluster. But a much more interesting one is this multi-data center load balancing policy, which is aware of your data center and will actually try to route the request first to your data center, to your local data center for your application server, and only if none of the local nodes are available, it will route some request to some remote data center. And once again, of course, it's simple for you to customize this behavior. And there's a mistake in this title. So here we are actually not doing a multi-data center load balancing policy, but a token-aware one, just like the one you could have in Asynchronous. That is, we will route our request to some nodes that are actually replicas, that are actually some replicas for the query we consider. So that the node that receives the request, that becomes the coordinator for the current request, doesn't have to forward it even more to another node, and which save a bit of latency. So that's something we provide to you. So once again, Patrick, in practice.
Yeah, we're going to have to kind of move a little quicker because we're almost out of time.
Indeed.
But because I want to leave a few minutes for questions. But there's not a whole lot to say here. Here, I'll take that clicker.
Yeah.
This is the same connection that I created before. But in this case, what I'm doing is I'm adding one more thing with my own load balancer policy. Now, this one is a default load balancer policy. I can create my own load balancing policies. Maybe if I wanted to go into certain racks of equipment, or I want to bias against certain servers, or however I want to load balance, that's fine. Whatever it is, you can do it yourself. And the default ones are probably going to be fine, but if you need to overload it, you can. Whoop. I'll let you talk on this one, and then I'll get the next one.
Just explain.
OK, so the retry, yeah, because that's the next one I have.
Yeah.
So the retry policy, I had written my own retry policy, and we were trying to figure out why we would do it, but I actually wrote a retry policy, and how it downgrades the connections is different. So a lot of people I tell, hey, whenever you're writing at quorum, if you want to maintain your maximum uptime, really you should fall back and try retrying at local, like a local 1. And so you do local quorum, and then you do 1. That's how you can fall back, and at least to that one level where you have a server that's available. So you can just automatically build this in with your own retry policy. I created my own retry policy that it was like during a time of day it wouldn't retry or something. I can't figure out a use for it, so I threw it away. So, but you could do that if you wanted to. It was kind of a cool exercise.
Yeah, right.
And I think, come on. There we go. Oh, OK, object mapping. I'll let you cover it. Do you want me to cover this real quick? So the object mapping is a future thing. This is going to be in the next version, right? 1.1?
Yeah.
1.1. And it's not JPA, but it's ish. So in my example where I was setting and getting user and video, in this I would create, in my object for user, I could put in annotations for each one of those properties. And using this, now I don't have to go and set string, get string, all that. I can just have it automatically mapped to an object, which is going to make my life a whole lot easier. But there's no relationships. It does not do relationships. Because why? Because Cassandra doesn't do relationships. You
Very important.
Last slide. Go ahead. You want to?
So you've probably seen this screenshot during the keynote of Jonathan yesterday. That's something very important for us in our strategy to move forward with a great experience for Cassandra developers. We've got a brand new query language, these much more efficient transport layers that let you simply drop Thrift if you want. We've got some new drivers that make it way simpler for you to work with Cassandra. And that's the last piece, at least for now, of our renewed experience for you with Cassandra. We'll provide you these tools, these IDEs that will actually let you execute some SQL statement, browse your data, explore everything you've got in Cassandra, and much more in the future. We've got a bunch of features in stock in mind for this tool. We want to make it really, really simple for you to debug and troubleshoot your Cassandra application in development mode and anything else. So yeah, stay tuned for this very interesting tools. We will release a beta version later this month, but somewhere at the end of June, so you can start to play with it. You can expect a final version later this year, and with a lot of updates later next year.
If you follow me on Twitter, I'll be talking a lot about it.
Yeah.
All right, so.
We don't have much time now, but anyway, you can ask some question or just come to us after. Yeah.
The retry policy or the load balancing policy? Load balancing policy.
So yeah, this one we passed on it pretty quickly, but actually this one is one of the retry policy we provide to you that you can optionally use, which lets you actually.
It fails down, and that's
yeah.
So you start a quorum, which is preferred because that's going to give you good consistency. But for whatever reason, I mean, there's plenty of reasons for your cluster and your data to be online all the time. And if you can't satisfy quorum, the choice is either take it down to 1 or fail. So if the choice of fail is not good, take it down to 1. Well, that should, up to this point, I've been having people do it programmatically, like in their own code, catch the exception, which is bad, and then deal with it. Well, now what we can do is just plug it in as a policy, and then it'll just automatically do that. And you can insert that into any time and say, oh, and for these requests, I want to use this retry policy.
And then in your result set, you will be able to realize that the query has eventually been executed with a downgraded consistency level. So you can do whatever you want in your business logic according to that. Yeah. That's a very good question. We
not today, because we're all here.
Not today. So back at the office, I will release it now. Actually, we expected during the summer. We've got several updates planned for 1.1, but we expected during the summer. So expected in July or August. Not yet, but it will be available in beta testing very soon by the end of the month. Any other question? Yeah. Yeah, maybe.
So as part of the failover policies and stuff in the retry, does it actually retry if the node has a timeout or that kind of thing, or does it only do it when the node is down?
Well, a timeout and a down almost are impossible to tell the difference. So what's the point? The intent is that you're trying to get data onto the node. Can't do that?
Right.
Try the next one.
Yeah, so that's why. So it does that, right?
Yes.
Okay.
Yes.
Then another quick question. So when the driver actually is communicating with Cassandra, is it still doing buffering, or have you switched that to be streaming?
That is, well, it's not buffering like Thrift. No, I mean, our CQL binary, and you can probably talk more about the binary stuff, but.
So in the native protocol, you still need to have all the data, all the results that you retrieve in memory. So the limitations that you add, like we were advising you not to fetch a too huge result set, not to overload your memory, is still valid. But the good news for you is that in Cassandra 2.0, you've probably seen in Johnson keynote, you will actually have a support for cursors that will be added. And in practice, in this Java driver, you will simply be able to iterate over your result set. And as you move forward in your result set, we will just fetch more and more results from the server. So, and obviously, you will be able to configure the size of the window of data that you want to fetch. So, yeah, we can basically call it automatic paging.
All right, no, that's a valid question. And so this is resiliency. So in normal operating procedure, you have, let's say you have a 4-node ring and you have a replication factor of 2 or 3. All right, quorum is what I would recommend always, because you're always going to get better consistency that way. And that's just the default too. 1 is where I'm making the decision that, let's say that it's something like user data on my screen, on my web page, I don't want my web page to go down if, for instance, I lose 2 nodes. I can't satisfy quorum at that point, but I can satisfy a CL of 1. So I'm making a decision in my application code to be able to do that. So if you're not okay with that, then don't use a retry policy. But what I'm doing is there's nothing wrong with trying to be consistent and quorum all the time. It's just, this is more like a safety valve. Say, okay, I want consistency level, but if you can't do it, help. Absolutely. As a matter of fact, I would instrument that. Oh yeah, and that's actually one of the things I did with my retry policy is I threw a log warning because I want to instrument that. I want to know that that happened. That's not a. Well,
Yeah.
It's as many 9s as you can put in your cluster, right? But if that happens, the operators need to know, and that's why I say instrument that thing.
So
Yes.
actually, you can configure your retry policy to add some logging in
Yeah.
it. Or actually, keep in mind also that the load balancing policy interface and the retry policy interface are pretty trivial, and that actually if you want to implement your own one or simply extend one of ours, it's pretty simple for you. So if you've got some very specific exotic business logic to integrate in your decision, it's simple for you to make it.
Yeah. Over here.
So I missed your data modeling thing, but we had, like, we're all CQL3, and we're using that index table pattern quite a bit. And
Right.
so we're running into that issue where you get back all these IDs of the objects you want to retrieve, and then having to do all these queries. One thing we had done is we had done some in clauses in there instead of having to issue get. Can you comment on efficiency of this new pipelining, the things one ID at a time versus using the in clause?
Well, all right, so we don't have any official benchmark. So what an in's going to do is going to do a multi-get, which is a API call on the server. So the coordinator's job is going to be that it's going to go out and gather that data and then stream it back to you or bring it back to you. When you're doing it this way with the threads, you're doing it from a client perspective. So which one's faster? Oh boy, which one do you think is faster? We're going to have a face-off.
I'm actually in the process of factoring out all those index tables because of all the round trips they were causing. I mean, is that something, if I switch to this, that maybe we should reconsider? That pattern of using the index table and having to do multiple queries instead of denormalizing more to get everything back in one query?
It sounds like you have some opportunities for efficiency, for sure. I mean, you're going to be able to take what you're doing already and probably make it more efficient with denormalization, for sure. I mean, if you're doing 10 round trips, yeah, okay. But you're not doing those calls in parallel, though, all right.
I had actually had to implement my own pipelining
Okay.
on top of Asynchronous for this, but it was still like, it's still like, now with denormalizing, it's so much simpler, so.
I don't know if you'll get, I don't know, what do you think? That doesn't sound like it's going to be that much faster.
Actually,
Was it a prepared statement, maybe?
well, you cannot prepare a statement with an in.
With an in, yeah.
So right now it's a limitation, and actually we are comfortable with that because we don't want to push something that we don't consider as the best possible practice right now. We don't want to encourage you to write some massive multi-gate, because we believe that it's a better approach to try to dispatch, to spread your gates as much as possible over your cluster, especially if your cluster is fairly large, you know. Right now you're not able to have a list of IDs as a parameter for, with a question mark in your in clause, in your select statement.
Yeah, we're really concerned about using the in statement. I mean, using the non-prepared query that way, so I think we'll be trying to pipeline.
Yeah, normally you should have some fairly interesting result with just spreading a bunch of a simple prepare statement all over your cluster. Once again, you can also consider if you've got really 10,000 of IDs to fetch, you can also consider sending some select statement with in clauses with maybe 2, 3, 4, maybe 10 IDs, not more, just for you to make some small batch, of fetch. But yeah, that.
We do have a lot of things where we pull back 10,000. Those are the things that seem like we have to be normalized.
Yeah, it may be the wrong pattern. Yeah, I think you might be onto that. All right, one more question, and then we've got to get out of here. Go ahead.
So, already we're having a Java shop. What's your plan for additional languages with
Yeah.
Yeah, well, .NET. That was on the title, right?
So
All this and .NET.
exactly. So .NET, we will release a final version of the .NET driver this month. Later this month, probably we plan to open source a Python driver. So you can expect a final version much later because we take our time to stabilize the API because we really, as I said before, it's a long-term investment. So we want these APIs to be here for probably a decade or more, and we want to be very satisfied of the first version because we cannot have some breaking change after that. So this Python driver, and then we've got some plans going on for all the other major languages. Obviously, we cannot support all the languages because there's a bunch of smaller community or smaller exotic languages that we won't support, but we want to have some plans either by ourselves or together with the community to provide some great option, following this kind of architecture that we try to promote for all the major languages. Okay.
Hey, the good news is I know that the Perl CQL3 driver is almost ready.
Yeah.
So there you go. Yeah.
Yeah, you can start scripting pretty soon.
Yeah. He actually
That's the
gave
good
that
news.
talk this morning. I was like, right on, man.
Yeah.
Perl lives.
You can go back home with a great news. Okay, so thanks everybody. We've got to go now.
Thank you.